Continuing along, so let's take a look at this first problem. A computer company wants to estimate the mean number of hours per day that all adults use computers at home. In a random sample of 32 adults, the mean length of time a computer was used at home was 1.7 hours. From past studies, the company assumes that sigma is 0.6 hours and that the population is normally distributed. Construct a 90% confidence interval estimate of the mean time a computer was used. So how we know what we're doing on this problem is that they say that we're computing a confidence interval for the mean. When you're doing anything for a mean, that's how we know we're going to be using Z's or T's. The question is which one. So right now I know because we're doing something for a mean, it's going to be Z's or T's. The question is which one. Well, they do tell me what sigma is. Remember, that's my population standard deviation. If they give me sigma, I'm definitely using Z's. That's the best choice here. So we're going to use Z's. So we're going to use Z's. We have sigma. That's a good thing. So we are going to, if we're doing this in our calculator, we're going to use the Z interval. So what we would start off by doing is opening up our calculator, hitting the stat key, arrowing to the right twice over to test, and then arrowing down to, I think it was option number 7. It might be different in yours, but that's kind of your idea of what we're doing. So, in your Z interval, you would want to make sure that they didn't give us a list of data, so that we're going to choose the second option on the right, which is we're going to run this as stats, that they gave us stats. And let's see what they asked for. They're going to first ask for the sample mean. That's not your sample mean. They're actually going to ask for your sample standard, your population standard deviation. They ask for sigma first, which we already have from our problem is that 0.6. Next, they ask you for your sample mean, your X bar, which is going to be, according to the problem, they told us that the mean length of time for your sample of 32 adults was 1.7, so your sample mean is 1.7. Continuing along, the next thing that they ask you for is your N. Your N is going to be your size of your sample, which is 32 adults, so we can go ahead and input the 32. And then the last thing that they're going to ask you for is your C level, your confidence level. Well, what kind of confidence interval did they want? They wanted a 90%, so that's what we're going to use is the 90% here. So that will get plugged in as a 0.90 or a 0.90, either or. So what it will look like in your calculator is the following. And so when you go down, you will have the following that you'll have in your calculator. And again, remember we chose stats. You'll enter in all the information we just talked about, and then you'll arrow down to the very bottom and select calculate. And then the first thing that gets spit out to you is your confidence interval. And my math lab will tell you exactly how they want you to round. I went ahead and rounded to 2 decimal places. So that would be that your confidence interval is 1.53 to 1.87. And you would be done. So it'd be 1.53 to 1.87. So if you wanted to work backwards a little bit, though, you could figure out a little bit more information, and it doesn't hurt to be able to do this. So what this means about your confidence interval, just to put this in context, is here's your confidence interval. It means that the mean went in the middle. Remember our mean, and if you forgot, you can go back up and look at your calculator, was 1.7. And we found out that the higher end of your confidence interval is 1.87. Your lower end is 1.53. So if you wanted to work backwards and find your error, you can. You can do one of two things. One, if you were trying to find the error, you can take the two ends of your confidence interval, the 1.53 and the 1.87, and let's see, subtract those two. And then when you're done with that, remember that that gave us two errors. Not one, but two are between the two. So you would divide by 2, and then that would get you your error one way, which would get us 0.17. Or the other way you can do it is to take the high end of your interval and subtract the middle of your interval. So you take your 1.87 minus your 1.7, which would still get you the 0.17 as your error. Or you can do the middle and the lower end, so subtract the middle, the 1.7 minus the 1.53, and you still get the 0.17 as your margin of error. Either way, it doesn't matter how you do it on a test. So this is kind of the worst case scenario. They can ask you for the confidence interval, which we already found was the 1.53, comma, the 1.87. They can also ask you for the margin of error, which was the 0.17. They can also ask you for the sample mean, which was the 1.7. You can work your way backwards, forwards, whatever you need to do.